In the second graphing vectors video, we're going to look at how to add vectors and also subtract and scalar multiply. So for adding, we're going to do this tip to tail method. We're going to draw the first vector, and then we'll draw the second vector. So the initial side of this vector coincides with the terminal side of the first vector. The resultant is going to be drawn from the starting point to the ending point. So the first vector to the last vector, if there's more than two, if there's only two, it's the first to the second. If we want to work with negative vectors, we're going to have a vector going one direction. I'm going to try to draw the same size one parallel to it. The only difference with a negative vector is we switch the arrow. So negative v versus positive v. So for subtraction, we are actually going to add the negative. If I want to do u minus v, I'm really going to do u plus negative v. So we're going to do some of this on the next page, but let's just say this is vector u. I'll use the same vector v from up above. So I'm going to do negative v. It's this one. When I draw this, I'm going to take u. That does not quite look like the u that I drew initially. Let's try it again. All right, we'll say that that's u. And then we're going to start from where we left off, where that arrow was pointing. We're going to draw negative v attached to that. And this is kind of freehanding, so you do the best you can when we have the actual graphs to do this with. It'll be a little easier. And then we are going to attach, this is my starting point, where I started from u to where I finished up with negative v. So that red vector would be u minus v, and would also be our resultant vector like described up above. Scalar multiplying is really just, if you think about multiplying, repeated adding. We're going to add the same vector to itself, that multiple of times. So remember a scalar from matrices. We did scalar multiplication. We multiplied a number times a matrix. It wasn't in a matrix format. When we're talking about vectors, it's a quantity that has only magnitude, no direction. So for example, we're going to take a number or a scalar and multiply it by a vector. So I'm going to take the u that I have up above, and I'm just going to attach three of them together. So this would end up being 3u. If you're doing this, you don't need to draw a whole new vector, although technically that's what I'm doing here. Over the top, that green vector would be 3u. You can just attach three of them together, or four, or whatever amount you're multiplying there to get your finalized vector. Oops, sorry about that. Okay, so we're going to take a look at doing this in 2 dimensions. What I do want to look at first is just how I would label these in component form, just to remind you of how we would do that from earlier. So vector w would be going 4 to the left. So we would do negative 4i plus 0j, or the b brackets negative 4 comma 0. Vector u, you're going to the right and up, so everything is positive. 3 to the right, 2 up. This would be 3 comma 2 in the brackets. And then vector v would be going 1 to the right, so 1i, or you could just write I, you don't have to write the 1 in front, and down 2, so minus 2j, or 1 comma negative 2. It's very important to make sure you use the v brackets, not parentheses, because a parentheses would mean we're talking about a point, not a vector. So if we're talking about initial terminal point, that's fine, but with a vector, you want to use those brackets that look like sideways v's. All right, so let's take a look at adding the vectors together. The first one is a nice simple, just regular adding, u plus v. So I'm going to start off, this is kind of tiny, so do the best you can with drawing this. Drawing vector u, going to the right 3 and up 2, and then I'm going to attach to the end of that vector v. I'm going to go to the right 1 and down 2 from there, which makes my resultant, I'm just going to make the resultant a different color. You can make it darker or label it with an R. The resultant vector is just going 4 to the right. So this would be 4i plus 0j. And if it doesn't specify what format, you can do either of these formats. And then our magnitude is easy. It's just going to be 4 because it's just going to the right. So we don't even need to plug it into the magnitude formula. Our next one we are going to be doing is w minus v. So here's what I'm going to recommend. We're going to do w first. We're going to go 4 to the left and graph that. Now if I want to do minus v, I might just take the exact same vector here and just draw it again. But instead my initial point is there and my terminal side is there. So I'm just going to draw negative v up on the top to help me with figuring out how to draw it on my graph. So that would be negative v there. We're going to the left and up instead of to the right and down. And then we'll connect for our resultant. Again, doing a different color. And the resultant vector for this is going 5 to the left, so negative 5i plus 2j, or you can write it in the v brackets. And then for this, we want to do for the magnitude, the square root of 5 squared plus 2 squared. I usually take the negatives out of this, the direction piece, because magnitude is just the distance. So the 5 and the 2 distance there, and we will get the square root of 29, which does not simplify, so we can leave it as is. All right, this is where it gets a little trickier for me to see. Well, at least I can see this one because we have to scroll back and forth a little bit. 2v just means we're going to connect. Here's my first one. Here's my second one. So that's just a nice little scalar multiplying. And when we do that, we get a resultant vector of 2i minus 4j. Now notice I'm not redrawing a vector over the top of that. If I have scalar multiplying with adding, that's when I would have to draw in the resultant. And then if I do my magnitude, it's going to be square root of 2 squared plus 4 squared. Comes out to square root of 20. In this case, you do want to simplify that into 2 squared root of 5. And then our last is 2u plus w. So just to recall, u is going 3 to the right and 2 up. So I want to draw 2 of those. And then w is going from there, where I left off, 4 to the left. And now my resultant vector is going from my starting to where I ended. So you're kind of just drawing a path and then getting that resultant on there. So this one is 2i plus 4j, or 2 comma 4. It's got the same magnitude as the previous one, it's just going in a different direction, so I don't need to recalculate that magnitude. All right, and on our last page, the graphing in 3D, for right now in the video, we are just going to do the magnitude. If you then have class time to discuss this, you will look at how to draw these and what it means to put this in an octant. So we're going to skip that part for the video and just do the magnitude for each of these. So our magnitude for this, And notice we have both formats of the vectors. We're going to be doing 3 squared plus 4 squared plus 1 squared. So just taking each of the components, squaring them. That's going to give us square root 26. And then for our second one, for the magnitude, we're doing the square root of 5 squared plus 7 squared plus 2 squared. That's going to give us square root 78. Also does not simplify. We will be able to do more work with the 3D when we work with the algebraic, but for right now, graphically, you need to see that visually in 3D first to do that, and that's not possible in a two-dimensional video. So that wraps up our graphing vectors lesson. You will now have some time to start on some practice.